which of the following statements is not correct? Okay, so let us discuss about these all 4 points, then we can say which is correct and which is wrong. Coming to the loose sands. Loose sand exhibits contractive behavior upon shearing. Okay, see, let us consider loose sand. This is ground level. So loose sand means there are so many voids in it, and it's loosely. So when there are, I am just exaggerating the figure. It doesn't mean that these many voids will be there in the loose sand. Okay. So as already coming to point A, as already many voids present in loose sand, it has it it undergoes contraction, okay, or compression upon shearing. For shearing to happen, we will apply load. Then what happens? Because of that, it gets compressed because voids are there. So air will be there. Air, air gets expelled out. So automatically it has so much place to get compressed. So that's how it is obvious that loose sands exhibit contractive behavior. Correct. Dense sand, when sheared under undrained condition, may lead to generation of negative pressure. See, in what happens in the dense sand means very densely packed. Okay, eight voids are very less, minimum possible voids. So if you take, so I'll put a void in blue color. Okay, now coming to the negative pore water pressure means, that means we are already talking about saturated, okay, saturated sand. So these, wherever voids are there, possible voids, it is full of water now. Okay, this is water. So now when you are applying load, undrained loading means here it is undrained condition. Under undrained condition means you are not allowing water to go out. Within that small time you applied load. You are not applying load very slowly. You are applying load very suddenly, where water is not getting time to go out. Okay, when water is not getting time to go out and you are applying load suddenly, what happens? And there is no space for the grains to compress. Already it is in compressed mode. So what happens? Because of that load, high load, these soil particles already, which are densely packed and having low voids possible, they try to roll over on each other. Okay, suppose something like this. Okay, something like this, they roll over on each other. When they roll over on each other, the minimum possible void will increase its size. The voids will increase because it cannot decrease anymore, and it has only choice to increase. So because of the displacement of the grains, when the voids will increase, air, a suction gets formed. Suction will be created. Okay, because of that suction, voids will increase. Then because of suction, it sucks water inside. So because of that is nothing but negative pore water pressure, which is right here in this context. And black cotton soil exhibits expansive behavior. See, black cotton soils are very low bearing capacity soils. It has so much of shrinkage behavior, so much of expansive behavior. In rainy season it will expand like anything. In summer it will shrink. Because of that, cracks will form. So it has two extremes. It will shrink more, it will expand more. So it is also right. And coming to the liquefaction is the phenomenon where cohesionless soils near the downstream side of the dams or sheet piles loses its shear strength due to high upward hydraulic gradient. See, here it is said that, uh, see, first of all, what is liquefaction? We should read that. Okay, liquefaction is something when effective stress becomes zero. Effective stress, which is denoted by sigma v dash, when it becomes zero, then it behaves like liquid. Behaves like liquid. Soil. Soil behaves. That is called liquefaction. Okay, that is called liquefaction. And here, liquefaction does not mean the downstream side of the dams loses its shear strength due to high upward hydraulic link. This phenomena, this phenomena is nothing but piping. Okay, this phenomenon is nothing but piping. Because of the hydraulic gradient, it loses its strength. Okay, because of that, again another soil gets eroded slowly, slowly, slowly. That phenomenon is called as piping. Whereas liquefaction is denoted by effective stress becomes zero, not at downstream, anywhere. Anywhere, if the effective stress becomes zero, that is liquefaction. Okay, so this is wrong. So answer is here D, because which one of the following is not correct? D is not correct. Okay, thank you.